Hello students, today we will study chemical bonding and molecular structure, question part 1. So we will practice some questions today related to this chapter. Disclaimer, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in the deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. So as I already say, so we'll practice questions. So today we will see 8 questions from 1 to 8. Okay. So let us see what are the questions. Question number 1. So question number 1 says that among the following electron deficient molecule is options are A CCl4, B PCl5, C BF3, D SF6. So you have to see that among this given compound which of this is electron deficient. So your time starts now. So let us see the solution. So first of all, what is electron deficient? So basically electron deficient means whose octet is not complete, right? So for considering this, the correct answer is C. So it is written here also that the compound in which the central atom has less than 8 electrons in the valence shell are electron deficient. Means central atom is when you will see CCl4, then C will be means the carbon will be in the middle and Cl4 will be the surrounding one. So therefore carbon will be the central atom. Now, one more terminology is used in case of electron deficient, and the opposite of that would be electron rich. So, for that also one terminology is used. So, for electron deficient, we call those compound as hypovalent. Okay. So, whenever you see an electron deficient compound, you can also call it a hypovalent compound. Similarly, an electron rich species is also called as hypervalent. Clear? So, instead of this electron deficient, question may be asked in this way also that among the following hypervalent molecule is sorry hypovalent molecule is, so you shouldn't be confused in that case. So first of all, let us consider this CCl4. So this is the Lewis dot structure for CCl4. Now you can see it very clearly that C is the central atom and Cl are the surrounding atom. Now what is the number of electrons on carbon? So it is 8. How it is 8? So we know that carbon has 4 valence electron in the shell. Okay, 4 valence electron in the ground state or in the neutral state. Therefore, upon formation of bond, it will form 4 bonds with chlorine, and each bond will donate one extra electron to the chlorine. So, to the carbon. So initially it was 4. So 4 bonds it can make. So 4 bond it is making, and each bond is contributing one more electron. That will count to a total of 8 electrons. So same thing is written here that 4 electrons from carbon and 1 electron each from 4 chlorine atom, and that would result in your 8 valence electron. Clear? Okay. Now moving on to the next one. So the next one is PCl5. So for phosphorus, for phosphorus, the valence number of valence electron is 5. So it is making the maximum bond also equal to that. So therefore each bond will again contribute one more electron other than the valence electron. That is coming from chlorine. Okay, 5 chlorines are here. So each chlorine is donating 1 electron extra. So that would result in total of 10 electrons. You can see it in this way also that there are 5 bonds and each bond has 2 electrons. So that means total of 10 electrons phosphorus will have. Clear? So 5 electrons from phosphorus and 1 electron from 5 fluorines, that would result in 10 electrons. Now if the question was asked that which of this is say hypervalent, then you would have chosen this, right? Because it is having electron greater than 8. Or if it was asked that which of this is a hypervalent, then also the answer would be this. And there are more options, maybe more options can be correct in case of multiple select questions. So let us see. The second, there is an option, so I am saying that. Now moving on to the option C, which is our correct answer. So option C is BF3. We have seen that. So you can see very clearly that this boron is forming 3 bonds and they are no lone pair because boron has 3 electrons in the outermost shell. So total of how many electrons will be for boron? So there will be 6 bonds, so 6 electrons. 1, 2, 3. 3 to the 6. So this one is hypovalent or electron deficient. Why? Because it is less than 8. This value 6 is less than 8, and 6 electrons are coming from 3 boron and 1 each from fluorine atom. Okay, so therefore this is our answer, which is less than 8. Moving on to the last option, which is SF6. Now sulfur has how many electrons? Sulfur has 6 electrons, and 6 of them are involved in bonding. Therefore, there will be total of 12 electrons on this central atom, that is sulfur. Clear? Now we can just calculate it also. Very simple. 6 to the 12 as there are 6 bonds. So therefore, it is also a hypervalent compound or a electron rich compound. So two of them are hypervalent. One is electron deficient and one is electron adequate. Okay, so this is the classification, I would say. So this is for question 1. Now moving on to the next question. Question number 2. Question number 2 says that sodium chloride is soluble in water but not in benzene because options are delta H hydration is less than delta H lattice in water. Delta H hydration is greater than delta H lattice in benzene. Option B, delta H hydration is less than delta H lattice in benzene and delta H hydration is greater than delta H lattice in water. Option C, delta H hydration is equal to delta H lattice in water and delta H hydration is less than delta H lattice in benzene. Option D, delta H hydration is less than delta H lattice in water and delta H hydration is equals to delta H lattice in benzene. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So first of all, what is asked here is that why is sodium chloride soluble in water? We know it very well. It is your say polar thing. So it will dissolve in polar, and so table salt is obviously dissoluble in water, but not in benzene because it is a non-polar solvent. But the question is asked in terms of thermodynamics, so we are considering the enthalpy change here. So keeping that in mind, our correct answer should be B. Now how will explain it? So for a compound to dissolve in water, the basic criteria is that the total energy that is being released during hydration or during the solvation process must be greater than the in lattice energy. Now why is it so? So basically when you dissolve something in water, now if it is polar and the solvent is also polar, like in this case, then what will happen? I'm telling about water. So what will happen? There will be an interaction set up between the positive part of the salt and the negative part of the water, like your Na plus and H plus and H of the H2O. Similarly, there will be an attraction between the oxygen of say your water and oxygen of water and sodium of sodium chloride and chlorine of sodium chloride and hydrogen of water. So there will be an attraction and that will be completely attractive in nature. So attractive forces will be increased. Now as a result, what will happen? So since it is attractive, the system will stabilize in terms of energy and it will release energy in doing so. Now that energy is the one which is working upon the breaking of the lattice. So if it is smaller than the lattice energy, then it won't be able to break that lattice. So this is the thing I am telling it here, right? So your hydration, upon hydration, the energy that is released, it should be adequate enough so that the lattice could be broken easily and you may get your ion. So basically in NaCl this thing is seen, okay, because of the proper interaction setup, it is soluble in water, but it is not in benzene because benzene is purely a non-polar solvent. So the same thing is written here that for water, the delta H hydration is greater, so it will be compensating the lattice energy that is required to break the lattice. but the delta at hydration is less than lattice energy in case of benzene, and therefore it won't be able to break the lattice of the sodium chloride salt. Clear? Okay. Now moving on to the next question. Question number 3. Question number 3 says that which of the following compound contain, in bracket we have S, no covalent compound, we have S. So the options are KCl, PH3, O2, B2H6 and H2SO4. So these are not the question options because it is obviously your compounds that are given. Now your options are A, KCl, B2H6 and PH3, B, KCl, H2SO4, C, KCl, D, KCl and B2H6. So you have 10 seconds to solve this question. Your time starts now. Now let us see the solution. So what we have to do is we have to see that out of these compounds that are given, which of these is not having covalent bond. So correct answer is C, which is for KCl only. So why is it so? Because KCl is completely an ionic compound, and ionic compound from ionic bonds and not the covalent bond, right? So this is very obvious to understand that all out of all of this, the KCl is ionic in nature, right? It breaks into K plus and Cl minus, and it is a salt. Now due to this, it has ionic bonds and not a covalent bond. Compared to that, all of the compound, that is PH3, O2, B2H6 and H2SO4, all of this are what? All of these are having covalent bond. So we can just see it here. So in case of PH3, you can see that this is the covalent bond. Again in O2, there are covalent bond. In B2H6 also, this is the covalent bond. So this is also shown in terms of orbital, right? And in case of H2SO4 also, there are covalent bond that are present. So overall, we can say that since each of these molecules, that is PH3, O2, B2H6 and H2SO4, all have covalent bond in their structure, where KCl is completely ionic and has ionic bond only. So therefore your correct answer will be C, that is only KCl, right? So this is your answer. Now moving on to the next question. So yeah, so this is your sulfuric acid. So first, okay, one thing is left here. So in H2SO4, all bond between SO and O are covalent. So it is mentioned here in terms of its literal meaning. So now moving on to the next question. So question number 4 says that the percentage ionic character in CS bond Cl bond present in CCl molecule will be if the electronegativity values for CC and Cl are 0.8 and 3.0 respectively. Your options are A 62.9%, B 60%, C 75% and D 52.14%. So you have 10 seconds to solve this question. Your time starts now. Okay. Now let us see the solution. What is the solution? So first of all, what is being asked here? So you are given a molecule which is CSCl, and you have to see that the bond that is present between CS and Cl. So what is the percentage ionic character in that bond? And what is being mentioned here is that it is given your values of electronegativity of CS and Cl, which is for cesium and chlorium. So it is obvious it will have cesium is electropositive, so it will have less electronegativity value, and Cl is highly electronegative, so it will have high electronegativity value. So let us see what is the answer is. So the answer is D. Now how I will solve it? So for that, first we will find the theoretical percentage ionic character. So for that we have this formula, which is 16 multiplied by electronegativity of Cl minus electronegativity of Cs, okay, and 3.5 multiplied by electronegativity of Cl minus electronegativity of Cs whole square, okay. If you just put this value, this 3.0 and 0.8, you will get this as, finally, calculation will give you 52.14. Okay. So this is your percentage ionic character. Very easy to solve. Just put this value, then you will get an answer. Okay. Now moving on to the next question. Which one of the following molecule is polar? Your first option is A, XeF4, B, IF5, C, SbF5, and D, SF4. So you have to see that which of these polar, and your time starts now. You have 10 seconds to solve this question. Now let us see the solution, what the solution is. So we have to see that which one of the following molecule is polar. So your correct answer will be B. And why it is B? Because IF5 is polar because it is unsymmetrical. And how is it unsymmetrical? So this is the structure of your IF5, right? So let us see how it is unsymmetrical first of all. So this must be creating a dipole moment, this bond, which is cancelled by this bond. Similarly, this bond dipole moment is cancelled by this bond. Okay, so this is okay. But what about this? Okay, so this is creating a dipole which is different from the dipole that is along your lone pair. Now this is creating a net dipole. Okay, and as a result of this net dipole, we will see that this molecule is polar. Clear? So what is the minimum requirement for a molecule to be polar? That it should not have a zero dipole moment. Now what about others? So if you just look at XeF4, then XeF4 is nothing but here in this place. So if you just see it here, that you will find that for XeF4, in the central part we will have Xe, and these F will be replaced by lone pair. Now again, this F and F will cancel out, and this F and F will cancel out. But since there is a lone pair, and this is a lone pair in case of Xe on both sides, so this thing also will be cancelled out, and your compound will be non-polar. Now if you talk about your say SbF5, that is trigonal pyramidal, so again in that case also each of the dipole will cancel out, and same will go for the CF4. So for all of these three, that is your XeF4, SbF5, and CF4, the polarity, the dipole moment is cancelled out, and they are non-polar. Wherefore for this, the dipole moment is there. Okay, so this is polar in nature. Moving on to the next question. Question number 6. So question number 6 says that which of the following pair has zero dipole moment? Your options are A, CH2Cl2 and NF3, B, SiF4 and BF3, C, PCl3 and ClF, and D, PF3 and NF3. So you have 10 seconds to solve this question. Your time starts now. Okay, now let us see the solution. So you have to see that which of this has zero dipole moment. So the correct answer is B. Why is it so? Because SiF4 is completely symmetrical and tetrahedral. So whenever you see a tetrahedral compound whose all substituents are same, okay, whether CF4 or CH4 or SiF4, you will say that it is polar in nature because all of its dipole moment are getting cancelled out. But and for the BF3 also, since all substituents are same, they will all cancel out each other, and you will get a non-polar compound which has zero dipole moment. Therefore, your correct answer will be SiF4 and BF3. Clear? Okay. Now moving on to the next question. Question number 7 says that so the bond distance in HF is 9.17 into 10 to the power minus 11 meter. Dipole moment of HF is 6.104 into 10 to the power minus 30 centimeter. The percentage ionic character in HF will be electron charge is 1.60 into 10 to the power minus 19 coulomb. So this question has been asked in JEE Main 2013. Your options are A 61.0%, B 38.0%, C 35.5%, and D 41.6%. So you have 10 seconds to solve this question. Your time starts now. Now let us see the solution. So how we'll calculate it? So for that, all data are given. The bond distance is given and your experimental dipole moment is given. So let us see what is the answer. So answer is D. How we'll calculate it? So the calculation for percentage ionic character is done by this formula, which is your observed dipole moment, which is given by the calculated dipole moment, which you will calculate using this data. Okay, multiplied by 100. So that is your percentage ionic character. Now, how the calculated means the theoretical one is calculated. It is calculated by multiplying the charge and your distance. Very easy, right? This is the distance. This is the charge. Simply multiply this thing, and you will get your calculated or theoretical dipole moment. So upon doing this, we will get it as 1.467 into 10 to the power minus 29 coulomb meter. Clear? Okay. And what is the theoretical one? So it is 6.104 in 10 to the power minus 30 coulomb meter. So this will be put in this formula. Okay. So 6.104 into 10 to the power minus 30 by 1.467 into 10 to the power minus 29 multiplied by 100. And that will give you 41.6% as your percentage ionic character. So in this way you will solve this. So the basic thing you should remember are two formulas, which is a percentage ionic calculation formula and your dipole moment theoretical formula. Okay, so theoretical value calculated formula. So these two things you should remember, and then you will be easily able to calculate or solve this question. Now moving on to the next question. Question number 8. Question number 8 says that among the following, the maximum covalent character is shown by the compound. So this is asked in AIEEE 2011, and your options are A FeCl2, B SnCl2, C AlCl3, and D MgCl2. So you have 10 seconds to solve this question. Your time starts now. Let us see what the solution is. So first of all, what we have to find is we have to see the maximum covalent character. Okay, so every compound has some covalent character and some ionic character. No compound is purely ionic or purely covalent. So we have to calculate that covalent character. So correct answer is C. So if you have solved it, what will be the explanation? So very easy. You have to apply the Fajan's rule. So what is Fajan's rule? So one thing you should remember, the basic criteria for Fajan's rule to be more and more say loud is that your cation, which is a positive charge ion, is should be large in size, and your anion, sorry, your cation should be small in size. Yeah, sorry, your cation should be small in size, and your anion should be large in size. And more the difference between the cation and the anion, more your covalent character is. Because what happens is that your small cation is having a large charge density, whereas your anion is big in size and its charge is dispersed. So as a result of this dispersed charge, the small cation is being able to say polarize or change the shape of the electron density towards itself. Okay. Now as a result of this, the electron density is attracted towards this small positive densely charged cation, and they form a kind of, or they develop a type of you can say just overlapping, right? That overlapping results in covalent character. So it is being given here also that in all the given compound, anion is same. Okay, Cl minus is anion. So your polarizing power is decided by whom? So basically the cation holds the polarizing power, and your anion holds the polarizability or the tendency to get polarized, and your cation is the one which is having the power to polarize. So since Al3 plus has the maximum charge, so it will the maximum polarization power. So there are two factors here. First of all, the greater charge will be having the greater polarizing power, and your smaller size is also a factor for the greater polarizing power. But the factor that dominates is your charge. Okay, so remember this thing also, that you will first look at the charge, and since aluminum has the greatest charge among all three, So it will have the highest polarizing power among all three. Therefore, your correct answer will be AlCl3, that is C. So this was all for today's session. Thank you.